Hello everyone, I'm Bindu Shriyam. I'm a final year student majoring in Electronics and Communication Engineering at Mysore College of Engineering and Management, Mysore. My teammates are Nagajoti MN, Chetan DS, and Gagan HR. We are here to present the project on microwave oven simulation which we have done on the internship which is conducted by the Emertxe Information Technologies. Firstly, let us see the contents. Microcontrollers, what is embedded systems, embedded C, components of embedded system, project overview, product simulation, and summary. Next is about the difference between microcontroller and microprocessor. A microcontroller is a compact integrated circuit that combines the CPU, memory, and input-output peripherals into a single chip. Microcontrollers are designed for specific tasks and commonly used in embedded systems to control devices and perform dedicated functions such as in applications, automotive systems, and industrial automations. Whereas microprocessor is a central processing unit of a computer or a general purpose computing device. It primarily focuses on executing instructions and performing arithmetic and logic operations. Microcontrollers are highly integrated and self-contained, whereas in microprocessors are less integrated. When it comes to case of use, microcontrollers are commonly used in applications where real-time control, low power consumptions, and tightly integrated with hardware peripherals are crucial. But when it comes to microprocessors, they are mainly used in general purpose computing devices such as peripheral computers, servers, laptops, and mobile devices. Microcontrollers are often more cost-effective for specific embedded applications due to their integrated design and target functionality. The microprocessors can be more expensive, especially when it comes to accounting for an additional components needed to create a complete computing system. The main difference between microcontroller and microprocessors can be clearly seen in below figures. Now, let us know about the contents one by one. First is about microcontrollers. A microcontroller is an integrated circuit which is capable of being programmed to perform specific tasks. A typical microcontroller includes a processor, memory, and input-output peripherals on a single chip. Embedded systems are applicable in various domains such as GPS system, medical devices, automotive systems, ATMs, defense and aerospace, home appliances, banking sectors, and many more. Categories of embedded systems. Embedded systems are broadly classified into four categories: real-time embedded systems, standalone embedded systems, networked embedded systems, and mobile embedded systems. Components of embedded system. An embedded system has three components. It has hardware, it has application software, it has a real-time operating system, which is nothing but RTOS. The RTOS will supervise the application software and provides a mechanism to let the processor run a process as per the schedule, followed by a plan to control latencies. The main benefits of embedded systems are reliability, cost effectiveness, low power consumptions, fast performance, and easy to manage. Trends in development: more computing power and new architectures, low power consumptions, more security, more local autonomy, and connectivity. Common design matrix: unit cost, NRI cost, size, power, performance, and flexibility. Next topic is about embedded C and which will be done by Gagan HR.
Hi, I am Gagan from Mysore College of Engineering and Management, and I will continue the project presentation. Firstly, let us know about the embedded C. Embedded C is the one of the most popular and most commonly used programming language in the development of embedded system. Embedded C programming plays a key role in the programming specific function by the processor. And using embedded C, one can write efficient and reliable code for embedded system, ensuring optimal performance and resource utilization. Next, project overview. In this project, we have developed a microwave oven using the PIC 16F877A microcontroller in PICSIM lab. In this project, microwave offers a precise temperature controller, adjustable cooking time, and a user-friendly interface. Introduction to microwave oven. Let us see what is microwave oven. A microwave oven is a kitchen appliance that heats and cooks food. Microwave oven converts electrical energy into a form of electromagnetic radiation called microwave. Tools required. Tool required for the projects are MPLAB XIDE, MPLAB XCS compiler, PixSimLab simulator. Let us see what is MPLAB XIDE. The IDE, which will be using embedded system development with PIC-MCU, is called MPLAB XIDE. It is product from microchip, which is so powerful and versatile. It is used to create new project and helps to write the assembly language program for interface. MPLAB XC8 compiler. MPLAB IDE by default does not include any compiler. We can use to write assembly language programs without need any compiler. But if we want to write code in embedded C language, we need to install a separate compiler. Hash include the xc.h header file contain the definition of all register of PIC16F877A microcontroller. After we finish writing a program, we will need to compile the code to generate the X file and to see if there is no error in the code. To compile code, click on build option. If there is no error in the code, it will display message successfully built and generate the X file. PixSimLab simulator. PixSimLab is a real-time emulator and development boards with MPLAB X debugger integration. PixSimLab supports several devices that can be connected to board for simulation.
Hi, I am Chetan from Mysore College of Engineering and Management. Now I am explaining about architecture P1C18F877A microcontroller. This architecture consists of GP input pin I2C, LR35, ADC, RS232, LED, buzzer, digital keypad, SSD, matrix keypad, LCD. The peripherals of P1C SimLab are LEDs, digital keypad, interrupts, timer, clock input, SSDs, LCD, matrix keypad, analog input. Now, let us know about the types of cooking modes. The cooking mode having 4 types of cooking modes. First one is micro mode, second one is grill mode, third one is conversion mode, and the last one is start. Micro modes. It is used in microwave oven to provide previous control over the cooking process. It is used for cooking good food and for the situations where we want to cook at lower power setting. By using the micro mode, we can ensure our food is cooked evenly and avoid overcooking or overeating. Next mode is grill mode. This mode used in microwave oven to provide to a grilling or broiling effect on the food. By using the grill mode, we can achieve a similar effect to the traditional drilling methods, but in a faster and more convenient way. The third one is conversion mode. Conversion mode is used in microwave oven to provide a combination of microwave cooking and conversion eating. It uses a fan and heating elements to circulate hot oil inside the oven, creating a more even and efficient cooking process. Last one is start mode. It has difficult 30 seconds timer which is used for heating, like if you want to heat the cup of coffee where does not need a much time, then we can go for the start mode.
Hi, this is Nagajyoti MN of MySim College, and now I'll be explaining about the project demonstration which we have done in this internship. Now let us move on to the project demonstration. Here, this is the code we have written for this project. Now we move on to the simulation. We have opened PixSimLab. Then we load the hex file. Now we have loaded the hex file. Now the micro oven is powering on, and we can see that the cooking modes, which are micro, grill, convection and start. We press 1 to avail micro mode. The power is 900 watts. For the convenience of our project, we set the timer to 5 seconds and press hash to enter. You can see that the timer is counting down and the fan has started. We press 5 to pause. You can see that the timer and the fan both have been stopped. We press 4 to resume the process. During the time, we can hear the sound of the buzzer, which shows that the cooking time is up. Now we press 2 for grill mode. Again, we set a timer of 9 seconds. Now, if we try to open the door in between the process, the buzzer goes off. We get a message to close the door, and the countdown continues. We can press 6 to stop the process. We press 3 for convection mode. The temperature should be below 250 degrees Celsius. If we say enter 300 degrees Celsius, we get a word name that is invalid. So let's enter 200 degrees Celsius. A preheating time starts of 180 seconds. For our convenience, we'll resume it after it reaches 10 seconds. We wait for the timer to end. There are only 10 seconds left for preheating. After this, we set the timer for 5 seconds, in which the actual heating process starts. We press 4 to avail the process to start mode. In the start mode, there is already a preloaded timer of 30 seconds. We press 4 to add 30 seconds extra. We can see that the time has been increased by 30 seconds. We press 6 to return into the main menu. That's it for the simulation. Thank you.